Hello, welcome. In this video, we'll learn about signals and then discuss the types of signals that exist. The first question that arises in your mind is, what is a signal? A signal can be defined as a sequence of values carrying any kind of information. These values can be physical quantities like temperature, pressure, mass, etc., or electrical quantities like voltage or current. Mathematically, a signal can be represented as a function of one or more independent variables. For example, the current in a circuit can be represented using one dependent variable, that is the current, and one independent variable, that is time. This can be plotted as shown in the figure. Another example is the brightness of a pixel in a grayscale image. The pixel can be located using two independent variables, that is the x position and the y position of the pixel, and the signal can be defined as the brightness with respect to the position. So in this case we see a signal in which the independent parameter is not time. Now we will discuss the types of signals. Consider this scenario. You are at the concert of your favorite singer and you're enjoying every moment of it with the help of your eyes and ears. However, your best friend cannot attend the concert, so you decide to record the performance for them. Here we come across two types of signals. The first is continuous time signals. When you're listening to the concert personally, what you feel is the variation of pressure at your eardrums with respect to time, and the value of pressure that your ear senses is continuous and can be any value possible, and the ear is sensing at every instance of time, so the value of pressure is defined at every instance of time. These signals are called continuous time signals. However, when you try to record the performance due to the processing limitations of your phone, the signal is sampled into at discrete intervals of time, and the values of pressure are also quantized to certain predefined values closest to the natural values. These type of signals aid in the faster processing and are described as discrete time signals. Now consider another scenario in which you are recovering from a fever in a hospital ward. There are two nurses that have been appointed to take your temperature. One nurse sits by your side holding your hand and sensing your temperature at every instance of time. But she is only using her hand, so she can only tell the temperature as cold, normal, or hot. However, there's another nurse who comes in at every 5 minutes and takes your temperature using a mercury thermometer that gives accurate values of your body temperature. So, when the doctor asks both the nurse, this is what they'll tell. The first nurse, who is sampling your body temperature at every time, will have a continuous independent variable. However, the dependent variable will be discretized into cold, medium, or hot. And in this case, we can see that your body temperature is decreasing, but she can only tell that it is either hot, medium, or cold. So these kind of signals have a continuous independent variable. However, the values of the dependent variable are discretized. When the doctor asks the other nurse about the temperature variation in your body, she can tell the exact value of the body temperature, but she can only tell the values at the instances of 5 minutes each. In this case, the value of the dependent variable are continuous, whereas the values of the independent variable are discretized. So here we see that either of the dependent or independent variable can be either discrete or continuous. So this gives rise to four types of signals that are possible. That is, either the independent variable can be continuous or discrete, or the dependent variable can be continuous or discrete. These are the four major types of signals that we come across in our daily lives. The continuous time signals, in which the value of the dependent variable and independent variable are continuous. The discrete time signals that are used for processing, in which dependent and independent variables are discretized. There are some signals in which the independent variable is continuous while the dependent variable is discretized, and the other signals in which the independent variable is discrete while your dependent variable is continuous. A point to note here is that whenever the independent variable is discrete, we use the notation of square braces to index the variable. However, when the independent variable is continuous, we use the notation of parentheses. So these are the major differences between the types of signals, and we also learned what is a signal in the beginning.